Okay, for this problem, we're asked to solve for V out, and we will start with this first operational amplifier. Okay, we will do KCL at the inverting terminal here. So KCL at Vn1, and that will be Vn1 minus 0.3 over 4K plus Vn1 minus V01 over 80K plus In. Okay, and we know by the ideal operational amplifier characteristics that In is going to be 0. So then we can work on grouping our like terms. So we have Vn1, 1 over 4K plus 1 over 80K minus V01 over 80K plus 0.3 over 4K equals 0. Now, the other thing that we know is that your current here equals 0. So if that current equals 0, that means our voltage going into that terminal will be equal to 0.4 volts coming from that source right there. So if Vp equals 0.4, then we know that Vn equals 0.4 volts. So we can use that to further simplify our equation. So now we're going to multiply everything by 80K. So we will have Vn1 times 20 plus 1 minus V01 minus 0.3 times 20 equals 0. And that means that V01 is going to be equal to 8.4 minus 6, which is 2.4 volts. Okay, so that is our voltage right here going into our second op amp. Okay, so moving forward, we're going to use that on the second operational amplifier. Okay, and what we know from looking at this one is that your voltage here is going to equal your voltage here. And what we know is that Vp2 is going to equal V01, and it's also going to equal Vn2. Okay, and now since this voltage is tied directly here, we know that VO2 will also equal Vn2, so that is going to equal that 2.4 volts. Now that we have that voltage, okay, we can use that to find V out. So we know that we do KCL at V0, so we will have V0 minus VO2 over 10K plus V0 minus 0 over 10K, which will equal 0. If we multiply everything times 10K, we will get V0 minus V02 plus V0 equals 0, and 2V0 equals VO2, which means V0 is going to equal 1.2 volts. Okay, that's it.